Yeah, hi everyone. Today I will be talking about vector. This is a series of C++ where I am having a playlist of STL, standard template library. See, if you are somehow preparing for online assessment round and wanted to do it with the help of C++, or are you for competitive programming, then I can say STL will be playing an important role. It will make your implementation very easy. Okay, so in this STL we are having a word called container. So in this container it's basically we can divide it into three parts. I already have written it into a notepad. You can just look at the see. It's first one. It's so-called sequence container. Sequence because here you can the way how you are going to iterate over the data. So on top of that, it is categorized into sequence associative container, and this one is derived. Sorry, this would be so-called derived container. So where you can just derive on another on top of another data structure. Okay, so here you would be uh, coming up with which is really very important. So you can say this vector. Sometimes it's DQ. Overall, you can say everything is important, but sometimes you might not be using this multi-map and the multi-set. This is not that much. Personally, I can say not in 100 time. I can say one or two time I have used. That's totally user choice, but instead, so you can just note it down. It's not that much important that you have to classify and how these are going to classify into this category. That is not an important call. So I will be covering today vector. It's one of the important thing. So basically what I found is we having some 5 to 6 ways to declaring a vector. I believe we should to know all those ways, because while implementation you might be sometime coming up with some sort of different implementation, not only the single type like how generally generic we do. Okay, so I will be discussing there is 4 to 5 ways. Let's see how. So first, it's simple type of declaration like how we do. It's generically I can say vector. Then we have to provide the data type. Right? What data type we are going to talk about? Suppose uh, vector VC1. Just I'm approaching it. So this data type, just pass it. This is the generic way and simple way. First way, anywhere you can get this one only. As well as we can pass sometime size. Right now I will be declaring it without size. Here you can say if you are unaware of size for now, okay, at that time you can utilize this one. So let's see. uh, right now I want to post some data inside this vector. So basically how what it is vector. So vector is nothing but it's an array, but but it's a, you can say, uh, special type of array which is dynamic. Okay, at runtime you can change the size. Runtime you can change the size. That's it. That is only difference in between the normal array and the vector. Okay, so its vector is nothing but an array, but a different type of array, you can see. Okay, so now I will be putting some data inside this vector. So first method, as we can know, that is the pushback method. Suppose I am pushing one data inside this. Now you can access this. Right now what internally happen, it will post this 19 inside this vector one. And initially the size was 0, and now this size is 1 here. As soon as we are putting any data, so internally how this size and capacity will work, I will be explaining you in the end. Just for now you can understand, as it was earlier 0, now it posted one more data, and now the size will become 1. So this happened dynamically, but in array that feature will not be available. Okay, so let's print. As right now it's one element is there, so I can access with the help of index. Right now 19 is there, so you can think like, okay, it's if it is right now as a vector, vector as an indexing value, so one element is there, so I can access it with the help of zero index. It is and I'm not looping as it's very small data. Let's run the code and check it out how, what and all. I have this 19. Okay, I will be using changing lines so that the next code should be in the separate data. Okay, so this is if we are unaware of size. Okay, so this one is so-called method one. I can say, let's do it now. I will be going for the method two. I hope so. This will, this you are getting it. So now here, let me think. I have this size. Let me take size in some variable sz1. Suppose only sz. Let's say just taking it as static data. You can take it with the user as well. So now we would be providing the size. Sometime we might having some fixed number of block in the vector that we need to take care while executing the code, that we are aware of. Okay, this will be only the size, it is not going to increase. So at that time we can directly pass the size. Okay, so here that we are going to do now, depending on your requirement, how we are going to put the data, that we can just, this is the second type of initialization. Now I will be putting the data in vector 2. See here, you will be getting some time. This is what this will do, what this is going to do. Okay, let's see. And there will be, as we are moving, this sz is only the block. So internally what will happen, it is going to create a block. It will be creating a block of size 10. Okay, so in the RAM at the runtime, it is at the compilation time only, here it will be allocating 10 memory. Okay, which is indexing from 0 to 9. Okay, so right now it having a block of 0 to 9. If you're going to use pushback method, it will be pushing a data at the end of the vector. So after 10th block, so it will be creating one more block and it will push the data into that block. So internally, or I can say technically, it will be placing the data at index 0. Okay, at index, sorry, not index 0, index 10. Okay, it will be placing at data at the index 10, or you can say block level. But we are not expecting that. So let me comment this one, and I will be putting data at some index. Okay, suppose it is 10. I have done. Now you just check it, what and all you are getting. So I will be getting value by static, and just for understanding purpose I'm doing this, as I can iterate the loop as well. So now it's printing 10. Let's suppose I'm going to use uh, what can I say, this loop, for loop I'm going to use, and I will show you how I'm going to associate, put the value inside the vector, and how can I can access those things. So let's see, I have the size till 0 to till size, that is basic thing. So right now I will be doing dot pushback as well as the indexing value. So here, suppose at index I, I'm going to do something called I into I plus I. For now it will be 0 into 0 plus 0, that will be 0. So it has been is associated, right now there will a value will be associated to each index. Now let me print that what I am getting at that particular index. Okay, now it's done. Let me change the line so that next output we can understand. Okay, see, whatever you can see, it is at index 9, 9 into 9 plus 9, 9 into 9, 81 plus 9, 19, 90. That's fine. So now let's go for pushback method. So you will see what and all thing will happen. Right now sz is 10, size is 10. What if I am going to do this vector 2 dot pushback some, suppose 100, let's say. Okay, now you can check the size, size method. No need to uh, remember each and every, no need to cram everything. You will be getting known while using. Okay, just use it properly, you will be getting done it. Now you just check the size, it should be 11. Oh, sorry. Sometimes Sublime makes this little weird. What and all is. Oh, sorry, sorry. I'm doing wrong. I'm doing wrong. No, I don't need this. Let's try it. See, size is 11, but what we are talking about only 10 size. Right now it is 11. Let me comment this and see. Only 10 will be the size. So it is not allocating into existing memory. It will create a new memory and will push that. That's why it is known as push back. Means it is trying to push the element at the back of the index. Okay. So these two methods we have done. Now let's move to method 3, where what I will be telling. Suppose you somehow are doing something where you have the size as well as you're trying to initialize the value. Okay, what I mean is you have the size as well as on each and every index you need an initialization. Suppose you want some time each and every index should having one value, and at runtime I will take decision and will modify the value. That is also a case might happen. Okay, so let's how we can do that. Right now we would be having definition of size comma value. So this is the generic way, and what and all I will be passing it. We have the sz size. Sz is 10. This is static I have allocated. Now value, let's store somewhere in the well. Suppose I'm taking by default as 1. Okay, you will see here each and every index on size 10. Sz is 10. So internally VC3 will be having a 10 block from index 0 to 9, 0 to 9, and each and everything will be associated with value 1. Okay, so let's check those things. I have already, let's check it. Okay, so here I will not be making any changes, just I will be checking how much value they are giving, what and all value is stored already. Let's see. So do we have change the line? Yes, we have changed the line. Why we are not 101? It's what? Okay, we have this VC3. Oh, sorry, this is coming the same line. Oh man. You can do control B and you will get the output. See, each and every index is with value 1. Okay, so in this way whatever you want, and at runtime you can decide, and whatever you want to change you can make the changes. Okay, so it's done. Method 3, it's really very important. You will get to know that is really uh, while you are using, while you are going to code at that time you feel, yeah, this method I should to use. So it's situation based, so whenever you are getting, you can do it. Right now I might be having some scenario like I already having a vector and I want an another vector which is going to use my earlier old vector. That is also possible. That vector might be sometime an array. Suppose right now I will be taking a fixed value. Suppose some particular value, some 3 to 4 value I need only. So I want that vector with predefined value. All these value I want at the same time. That is also we can do. See how can we try that. So just I will be doing it. If you need a static value, all the value at the declaration only you want, you can use this curly braces and put all the value whatever you are having. Okay, suppose I have done this. Let me check it. We no need to the write this further. We are having this so-called VC4. Okay, each index you just check it. Right now SZ will not be a good thing because SZ having 10 index. Right now we have declared with 4 only, so that is not correct one. So let me override this SZ with VC4 size. I have this method so-called size. Okay, so let's check it. What it is 1 2 3. Sometime you might be coming into this. Suppose I separate it into an array. That is just a different ways how we can do. let's say method 5, or you can say, or else you can treat it as normal thing. It's not a big deal. Okay, so right now suppose I am having an array with some. Okay, now I will be using the same thing how I have done. Okay, size is already over it. You can use this size every time, but it's depend on you what how you are getting the size. So now I have this array, but I will be using one more vector where I will be defining this vector on top of this array. Okay, so it is vc5. Just we are going to use this array plus size. This is the so-called iterator. If you are unaware of this, you can check my another video for the iterator, how we can iterate a value. So from index 0, you can take it as this way also. Sorry, to this sz. Now you just iterate and check what and all value we are having. So it is vector 5. Let's check the output. See, 1 2 3 4. So it is nothing but just a vector, same way how we have done here. Just we are putting this value into a vector and we are associating it with the help of iterator inside the array. That is not a different call. I can say method 4 and 5 both are totally same, just how you are approaching it. Now the next method which I can say, it might be sometime you are getting it into useful. Like suppose right now I am having a vector, this suppose vc2. Okay, this vc2 I want to utilize their content into my another vector, so called vc6. Let me create that first. So this is I will be utilizing in this vc2 I will be utilizing here. So vc2 how I am going to utilize. So as it is vector, so I have to pass the iterator from first index to the last, whatever you want. Like suppose I want all the data from index 2 to suppose index 4. Okay, it will take from index 2 to index 3. Okay, because it is going to exclude one last, it will just refer to the last of means next to the last, whatever you are expecting there next. Okay, so if you are expecting third, then you need to pass the fourth index. So it will exclude the last one, whatever you are mentioning here. So it will be taking vector 2 from index 2 to index 3, and it will be a part of our answer. So let's say size, I can take. I cannot blindly take sz because we are not having that one. Okay, so this is what happened. Okay, so now let's iterate this once again and we'll see what and all output we have. And you just see what value we are having in vector 2. Everything is fine, hope so. Yeah. What we have done, okay, this is we have done wrong. We have to pass it properly. Let's see. Okay, see, you can see only 6 and 12 is coming, 0 1 2 2 to 3 index. You can see, right? Let me tell this one. You start from begin and you go till end, or I can take, we have one more iterator, so called end. Okay, what it will do, it will be copying all the element of vector 2. It will start from begin, or you can say index 0 to, it will be referring to one last to the index, sorry, one last to the last index. So it will be referring after 90. Just exclude that, so it will come up to 90. So see the output, it will be as it is whatever we are having in vector 2. I can say this is one of the important thing which you might be using it regularly. Okay, next method we can consider, that is a fill method. Sometime you might be coming up with this one. So what it is telling, it will tell you like you are already having a vector, and you are trying to fill some data inside that vector, means you are trying to modify a vector. So at that time this fill might also be come into picture. So suppose I want to edit this vector 6. First you have to pass, it will be taking as a sequence. See, fill will tell you, okay, you just tell me from where to where you want to edit your data. I'm going to mention this one. Suppose you start from index 0 and you go till suppose 2 index. Okay, till 2 means total 2 data I want to change. So begin to, it will be going till the index where you have provided the last one before that only, as it is going to exclude. That's why you cannot consider this third index. Okay, so third will be excluded internally. Now just check it, what and all we will be getting in this vector 6. So it is nothing but it will be making change on vector 6 only. It is not going to return any data. It will be internally will change the data. If you're trying to return something from the fill method in a vector, that will not work. So now we will be checking only this vector 6. Okay, we are already having this sz updated value with vector 6 only, so we can comment this one. There is no use of this. Now you will see there will be some changes, but what and all we want to change, so we forget to do that one. So it will take the address, or you can say the location from where to where it want to make changes and what value. So now let me say 123 I want to put from index 0 till index 2, as this will be included third one. So till 2, so 0 1 2, it is just telling that how many element you need. So it will tell you from this index, so in a generic way I can say, suppose it is 0. Let me think, just take care now. I, and it say this one as j. So it will be telling, okay, you tell me this much counting from j minus I to plus 1. So in the same way, you just replace the value I equals to 0. And suppose j equals to 3. So this number of container, this number of element, it will try to access. So how much it is? So 3 minus 0 plus 1. Okay, so it will start from 3 and it will try to end up just, sorry, this should be minus 1, not plus 1. It should be the minus 1. Now you can just calculate, it will be 2 in total 2 element it is trying to make changes from index 0. So from 0 to 0 1 and 2. So you can just check this one if you want. Okay, leave it. So now in this, what and all thing will be changed, that will be from index 2 and the value will be 123. Just check. See, 0 1 2, it is being 123, and else whatever it is earlier, so that is same. So in this one you can see 12 20 30, everything will be same. Basically we are referring this one which is referring the vector 2, so everything are as it is. Okay, so yeah, that's fine. This is all the method which you can think of in vector. And one more thing, we are having capacity and size. Okay, so capacity and size, what it is, let's see. So capacity is telling, like for a particular, for a current vector, how many element they can contain. Okay, and size is telling actual how many element they are having right now. So capacity will be telling, okay, whatever size you are having, but exactly maximum size how much you can hold for now for this situation. So exactly what happen internally, it will tell you whatever value you are having right now. At that time, if somehow it need more data, means capacities, whatever capacity they are having, now more element it want to consume. Okay, at that time this will tell, okay, I don't have that available capacity, I will try to increase the capacity. So earlier capacity whatever it is, the new capacity will be twice whatever it was earlier. So just check it into the picture. See, I have a suppose vector of v, where I will be telling right now I don't have any element. Just check the output. what and all I have the size. Okay, sorry, so set man. Okay, so you just compare what and all I will be having in this capacity and size. Fine, let's check this first. We are having this. Oh shit, this is left man. Yeah, you can see this is 0 0. Let me separate it first. So you can think, okay, right now both of them are same. So let me put some data. I will be pushing one data. Now you can check, just check it. See what you are getting, 1 1. Right now he's telling, okay, I have only one capacity. But next time, if I'm going to put one more element, as he having only, see, this time this is a so-called base. So at this time it will try to increase the data. I will tell you at the end what and all this is base case, how it is being handled. So now let add one more data first and see the changes. Oh, sorry, we haven't print this. We print it first. See, 2 2. For now, one more element has been added as pushback. So size became 2, but earlier capacity was 1. So internally, this vector is trying to double their size, which will be nothing but the capacity. So whatever earlier capacity it was, it will make it double. Earlier capacity was 1, now it's 2. As well as size is also 2. So no changes till now. But now you can see some changes you will be able to see. Just see this one. What and all difference we are having? 3 and 4. So capacity is going to be double, but size will be as it is. Now from the next time, when we are going to push one more element at that time, this will tell, okay, I have the 4 capacity, but right now I am having only 3 elements. So yeah, I can tell you, okay, you can add one more element. That is fine for me. So let's check this. This time we are expecting no capacity change. As this capacity is telling, okay, I have that capacity, you can put 4 element for now, but already 3 element is there, so 1 element is left. You can put one more element. Till now I will not change, it's fine. From the next time when you're trying to make changes, anything in the size, it will tell, okay, I have the capacity 4, already 4 element are there. If you're trying to add any one, I would have to change. I will shrink or stretch, I will have to take care. So okay, it's 4 and you want to push one more element, capacity is 4, so I will get double. This time you will see size would be 5 and capacity would be 8. Just check it. Right now you can put 3 more element, and till that time it is not going to be changed. So it is nothing but it is following 2 to the power whatever earlier it was, it will just add one more, means it will multiply the capacity by 2. So this approach they are going to utilize while changing the capacity. So what and all condition is there? Suppose first, if capacity is greater than size, if capacity is greater than size, it's not an issue, no change will happen, no change on the capacity. Okay, but see, if capacity is less than or equal to size, right now obviously capacity can't be less. If it is getting less, then it will make the changes, make changes, and what and all changes will be happening. So these changes will be equals to nothing but capacity into 2. That is only make changes. But see, if right now it is equal, then only it will make change. But at the time of less than, capacity is less than, means internally if we are adding one more element and it is already equal, at that time this will getting double. But see, if capacity is somehow greater than size, then there is no changes. Okay, but think on the first time we having capacity of 0, what size is also 0. The next time it is telling you are trying to add one more element, so I would have to getting double. So 0 into 2 would be what? 0, but it is 1. So this is, you can think of the base case. They have handled this base case with, if it is coming at 0, the next time it should be 1. From the next time it would be multiplied. That is fine. That is fine. So everything will be okay. So this is really very important. That's an intuition based thing, like how this dynamically data is being changed on the vector. Okay, so I believe this vector would be clear for you. This is one of the backbone, I can say, for the STL or C++ developer, obviously. Okay, so that's fine from my side. Let's wait for another video where I will be discussing about the next container. Most probably I will be talking about map, which is really very important. Thanks for watching, man. We'll see you the next time. Yeah, bye.